Good morning, everybody. We are starting Unit 9 today. So we're doing Unit 9, Lesson 1. So I have attached the files to the classroom so you can access the whole Unit 9. Certainly, if you're able to print it, go ahead and do that. If you're not able to print it, write it on loose leaf. If you could do me a favor, though, and write the unit on top of the homework page, that'd be really helpful for me when I'm going and putting in your homework checked in. So let's do a quick do now. We are going to today be looking at square roots. But before we do that, I want to back into where the square root numbers come from. We're going to understand what it means to be a square root and how to simplify square roots today. So let us do these quick two do nows. 5 squared, we know 5 times 5 is 25. Okay. How about -7 squared? Well, -7 times -7 is +49. Remember, you're smarter than your calculator. So you definitely want to make sure that when you're doing negatives squared, you want to put parentheses around it if you're going to use it in your calculator, okay? So let's jump to question 1. So square roots, cube roots, and higher level roots are important mathematical tools because they are the inverse operation of squaring and cubing. So the square root is the opposite of squaring, and the cube root is the opposite of cubing. In this unit, we'll be able to study these operations as well as numbers that come from using them. Let's go through some basics. The first few exercises are super easy. You could probably blow through them, no problem. But don't forget, when it gets toward the end, I think it's question 7, pause and let me go through it with you, okay? So find the value of each of the following principal square roots. Write the reason for your answer in terms of the multiplication equation. So the square root of 25, we know is going to be 5. And how do we know that? Because 5 times 5 is 25. Okay. The square root of 9 is 3. How do we know that? Because 3 times 3, or 3 squared, is 9. How about 100? The square root of 100 is 10. How do we know that? 10 times 10 is 100. Okay. Go down to the more challenging one. Square root of 0 is 0, because 0 times 0 is 0. Square root of 1/4. The easiest thing to do is to break them both into square roots. We're left with 1/2. How do I know that? Because 1 times 1 is 1, and 2 times 2 is 4. Okay? Final one, square root of 64 over the square root of 9. So the square root of 64 is 8. The square root of 9 is 3. How do I know that? Because 8 times 8 is 64, and 3 times 3 is 9. Okay? So square roots of fractions, don't get upset about them. They're not difficult. Okay? So it's generally agreed upon that all positive real numbers have 2 square roots, one positive, one negative. We saw that in the do now. We had the -7 squared is 49. We know also 7 squared is also 49. We simply designate which one we want either by including a negative sign or leaving it off. Question number 4, give all square roots of each of the following numbers. So we can have 2 times 2, which is 4, and we can have -2 times -2, which is also 4. So the 2 square roots are going to be -2 and 2. 36. So again, we can have 6 times 6, that equals 36. That one's no problem. And -6 times -6, which is also 36. So our answer is -6 and 6. Last one, 1/16. We can have 1/4, and we can have -1/4. Why is that the case? Because -4 times -4 is -1/16, and -1/16, and we have +1/4 times +1/4 is +1/16. So my solutions are -1/4 and 1/4. Okay. All right. So let's go to question 3, which is a substitution problem. Given the function f of x equals square root of x plus 3, which of the following is the value of f of 46? Remember, when we have f of, that's going to replace the x. So let's go to f of 46 equals square root of 46 plus 3. Well, we always, underneath the radical is considered a parenthesis. So clean up the parenthesis first and then do the math. So 46 plus 3 is 49, and the square root of 49 is 7. So the correct answer here is 4. Question 4. Find each value of the following products. So let's talk about the difference between A and B. If you notice, I'm doing the two radicals separately. Radical is another word for square root. And I'm doing the radical together. So let's see if we get the same answer or not. Square root of 4 is 2. Square root of 9 is 3. That equals 6. Let's do it together. Square root of 4 times 9, we do the math first. So we do 36. Square root of 36 is 6. So they are the same answer. How about the square root of 4, 2, times the square root of 25, 5. That equals 10. Let's see about the square root of 4 times 25. We do the math and underneath first, which is square root of 100, which is 10. Oops, I don't want the square root. Sorry about that, which is just 10. So that's how you do those. Okay, so you can see that they are actually equivalent, whether I break them apart or keep them together. And this is going to be important in the next few moments. So you can see that if I have square root of A times the square root of B, it's the same as square root of A times B. Similarly, if I have the square root of A times B, it's the same as the square root of A times the square root of B. So they want us to find the results of each of the following products. Now, if you notice, in question A, neither square root of 2 or square root of 8 are perfect squares. I have to first do the math to do this. Do not use your calculator for this, everybody. So I'm going to do square root of 2 times 8, which is the square root of 16, which we know is 4. See whether you can do B on your own. Pause it, and let's see what we get. Okay, so we get square root of 12 times 3, which is the square root of 36. Square root of 36 is 6. Last one, C. Square root of 20 times 5. So neither of those are perfect squares. So I'm going to do the square root of 20 times 5, which is the square root of 100. And the square root of 100 we know is 10. All righty, let's move on. I would like for you guys to list out the first 10 perfect squares. Let me show you how you're going to do it. You're going to do 1 squared, which is 1. 2 squared, which is 4. 3 squared, which is 9. Keep going. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81, and 10 squared is 100. Okay, make sure you memorize those. They should be probably memorized somewhere in your brain anyway, but those are going to be used a lot. We want to try and use our calculator as little as possible until we need to in a few lessons. Consider square root of 18. Which of these perfect squares is a factor, divides into 18? What you want to do is you want to start with the number right before the 18, in this case 16. Does 16 go into 18? No, it doesn't. Does 9 go into 18? Yes, 9 is a factor of 18. They want us to simplify radical 18. This is what we're going to do. Just like before, when I was able to take a number and break apart the 18, square root of 18, I'm going to break it apart and do 9 times 2 under the square root sign. So I can then break it apart if I want to square root of 9 times the square root of 2. Square root of 9 is 3. The square root of 2 is not a perfect square, so I'm going to leave it as 2. So 3 radical 2 is equal to square root of 18. Okay, so all of a sudden we went from like easy lesson to, ooh, this is a little hard. I don't think you guys did this in Math 8. Maybe some of your teachers did. I don't think so though. All right, so let's do some practice with that. So each of the following radicals has a number under it that is not a perfect square. They want us to find the perfect square that is a factor, and then they basically pull out that perfect square and you're left with a non-perfect square underneath the square root sign. So let's do this. Square root of 8. So I think about square root of 8. So the first number that can come through, by the way, sometimes what I do is on my page, you guys have it in front of you, I don't. I'm going to quickly write down the first perfect squares. 9, 16, 25, 36, 49, 64, 81, 100. So that way I can kind of quickly, refer back to this list. So let me pull this up here. Okay, fine. So square root of 8. So I am going to say, okay, square root of 4 times the square root of 2 is equal to the square root of 8. Square root of 4 is 2. Square root of 2 is not reducible, so I'm left with 2 radical 2, and I'm done. Okay. Square root of 45. What is the perfect square that goes into 45? Let's start here. 45. 36 does not go into 45. 25 does not go into 45. 16, no. 9 does. So I'm left with square root of 9 times the square root of 5. If you want to use your calculator for this, the only thing I would suggest you do is, maybe going to y equals and going and, get some of the stuff out of here, and going and doing x divided by, 45 divided by x. That way you can see some, and then go to second table, and you can see the different perfect squares that might appear. And sure enough, there's 5 and 9. Do not use the calculator to find the exact value of square root of 45, because guess what? This is the exact value. We're left with 3 radical 5. You're going to be left with some repeating decimals. We'll talk about that soon, but that's your answers for B. Look at C. What is the perfect square that is a factor of 48? Okay, so maybe you're not sure. Let's go to y equals, and let's change the 45 to a 48, divided by the square root of x. Second table, lots of options are here. I have 12 and 4. Ooh, that's a good one. 3 and 16. So 4 is a perfect square and 16 is a perfect square. Nothing else is that I can see on this page. Here's the situation. You always want to pick the largest perfect square. So in this case, the largest perfect square is 16. So I'm left with square root of 16 times the square root of 3. The square root of 16 is 4. And the square root of 3 cannot be reduced any further, so I'm left with square root of 3. So 4 square root of 3 is the final answer that is equivalent to the square root of 48. So let's look at negative square root of 75. So square root of 75, I probably don't really need to do much work here. I know that 64, 49, 36 don't go into it, but 25 does. So I'm going to write negative square root of 25 times square root of 3. Square root of 25 is 5. Square root of 3, I can't do anything with, and I put the negative in front. So negative square root of 75 is equivalent to negative 5 square root of 3. By the way, we always write the number first, and then we write the square root. Okay, question E, starting to get a little tougher. Again, I want to find the largest perfect square. I'm pretty sure 4 goes into it. I'm pretty sure 9 goes into it, but I think there's one a little bit bigger. So let's go to y equals 72 divided by x, and I'm going to do second table. So what do we have here? 418, okay, 324, they're not perfect squares. 236. 36, is that the largest one that goes into it? Of course it is, because the other number's 2. 2's very small. So I have 36 under the square root sign times square root of 2. Square root of 36 is 6, and then square root of 2. Last one, square root of 500. Again, we're looking for the largest perfect square. So I know 25 goes into 500, but you know what else goes into it? 100. So I'm going to do negative square root of 100 times the square root of 5. I'm going to pull out the square root of 100. Square root of 100 is 10. Square root of 5 comes along for the ride, and I put a negative in front, and that's my final answer. Okay, our homework is Unit 8, Lesson 1, and you have a wonderful day. Bye now.